So welcome to today's lesson, which is on pressure. So there's three learning objectives today. Know and use the relationship of pressure equals force divided by area. Understand that pressure at any point in a fluid, which is a gas or a liquid, at rest acts equally in all directions. And know and use the relationship that the pressure difference in a particular point in a fluid is equal to the height times the density times the acceleration due to gravity. So what is pressure? Well, pressure in its simplest form is the amount of force applied over an area. So pressure equals force divided by area, where force is in newtons, area is in meters squared, and pressure is in pascals. Force can also equal pressure times area, and area also equals force divided by pressure if we rearrange the equation. It's important also to note that 1 Pascal is the same as 1 Newton per square meter. What's the force applied in a unit area? So the 1 Pascal essentially is equal to newtons per meter squared. So why do off-road vehicles like tanks and these kind of trucks we see on the right there or left there have tyres or tracks in the case of tanks? So in both cases, what they're doing is trying to increase the surface area in contact with the ground, okay, because the force being applied is going to be the weight of the object, okay, mass times the acceleration due to gravity. So these are quite heavy objects, they have quite a large mass, and because of that, they want to reduce the pressure they're exerting on the ground, because if they have too much pressure, they're going to sink into the ground. They want to reduce the pressure, so the way to do that is increase the surface area, and that's why they have large tyres or tracks, because weight divided by area, as area gets bigger, the pressure being exerted is less and less. So this is how a gas essentially exerts a pressure. So a gas or a liquid, basically a fluid, consists of molecules which are all moving about randomly, and then when that molecule of either a liquid or a gas hits the surface of the container, the inside surface, it reverses direction, bounces off basically, due to the force being exerted on it by the surface. Okay, Newton's third law, every action has an equal and opposite reaction force. The molecule in turn exerts a force back on the surface, and this force is what actually creates the pressure, because pressure equals the force divided by the area. Okay, so for a particular particle as well, you must be aware that the force or pressure is the same all around that particular particle. Okay, it's uniform. So the pressure, that's basically what I'm saying, the pressure in a liquid or a gas, which is collectively known as a fluid, at a particular point acts equally in all directions. That's at a particular point. Okay, that's the key phrase. Obviously, the particle's going to move around, so it'll experience pressure variations. But at the same depth, okay, that's what we mean by a particular point, the liquid has the same pressure in all directions, because the force is going to be the same in all directions. Okay, so you can see this, how pressure varies with depth by having a container which has holes at different points from the surface. Okay, so the pressure you can see increases with depth. How do we know that? Well, you can see from the image that the amount of water, well, the pressure basically increases with depth, because the amount of water being pushed out, the distance from the container increases with increasing depth. Okay, illustrating that the particles at that particular depth are experiencing more and more pressure. So at the bottom, pressure is the most, and at the top, pressure is the least, because the mass is less at the top compared to the mass being forced down at the bottom. Okay, this is where this equation of pressure difference comes in. The pressure difference equals the height of the container, or the height of the hole in the case of the previous example, times the density of that particular fluid, times the acceleration due to gravity, okay, because that's going to give you a measure of the force being exerted on that particular particle at that particular depth. So the height or depth is in meters, which is given by h. Density is rho, which is kilograms per meters cubed. gravitational field strength is G, which is newtons per kilogram, and the pressure difference is going to be in pascals, because that's the measure of pressure. Okay, so that's pretty much all you need to know for pressure. So you'll be asked questions relating to those two equations, and that's it for today's lesson.